All right, today we're going to talk about indirect measurement. And what indirect measurement is a way to solve for missing sides of triangles. And we're going to be able to use what we have learned about proportions and ratios to be able to do that. So let's kind of review what we know about similar polygons. Okay, similar polygons, we have to have congruent angles. And we have to have proportional sides. Okay, well, because triangles are so special, we can actually assume that triangles are similar with very little information, okay? So what I mean by that is there are 3 ways that we can show that triangles are similar through the variation of what is congruent and what is proportional. And so what that means is when we did back in Unit 4, when we talked about triangles being congruent, there was an order that the congruency had to be in. So remember side, 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 angle, side, angle, side, angle. That will kind of trigger some memories for what I'm about to write down, okay? But in order to see if triangles are similar, there are only 3 different ways we can use, and we can actually use angle, angle, angle. Okay, meaning all 3 angles are congruent. We can use side, 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 which means all 3 sides are proportional. So we have proportional sides. And then we have side, angle, side, meaning there is a congruent angle in between 2 sets of proportional sides. Okay, now these aren't super important right now. I'm not going to ask you to say, hey, are these triangles similar through which congruency or which statement? I'm not going to ask you that, but it's just me telling you, hey, the reason why we only need little information to say that these triangles are similar is because of these 3 reasons, okay? So the reason we're going to be able to solve the questions that we have right now is because the triangles are already similar through either AAA, SSS, or SAS, okay? All right, so because, and like I said right here, so similar triangles can be used in indirect measurement. And so here's what that means. In example 1, we have a smaller triangle, and if you see it, this smaller triangle inside the bigger triangle, okay? And that's what indirect measurement is, okay? So when we're trying to find the value of x, we are still going to use proportions, okay? But we have to be careful on some of the information it gives us. So let's kind of decide what kind of proportion we want. And I'm going to put, like I always like to put the big triangle on top of the small triangle. Okay, so let's kind of decipher what the big triangle looks like. So the big triangle is this whole thing right here. It's the value of x, as you can see, and it is also the value of 22. The smaller triangle is what's on the inside right here. So the one with 10 and the one with 5. Okay, so if I'm trying to find x, I'm trying to find something on the bigger triangle. All right, so now let's set up a proportion. So if I want to find x, I'm going to put it on top. And which side corresponds with x on the small triangle? Well, 5 corresponds with x, so 5 goes here. And then we're going to use the other big measurement for the next ratio, so of the big triangle, so 22 over what corresponds with that one? Well, 10 does because it's in the same position. And then now we just cross multiply. So we have 10 times x and then 5 times 22 Okay, so we have 10x equals 5 times 22, which is 110. And then we need to divide by 10. X equals 11. So that means this value right here is 11. All right. So I'm going to set up number 2, but I'm going to have you solve it. Okay. All right. So if we're trying to find what the value of x is, and I always want to put big over small. Okay. All right. So the big value, the big triangle is this triangle right here. The small triangle is this one right here. So that means it includes 8 and 3. And then the big triangle includes 6 and x. So now we just need to put it in corresponding order. Okay, so the big value that we have 6 and 3 as the small one. That corresponds. So we're going to do 6 over 3. And we're going to set it equal to the other big value that we're trying to find, so x. And x corresponds with 8. All right. So I want you to solve this.